In this video, I want to draw attention to just one aspect of fraction education, and that is the idea of models and representations. So take a look down here at the examples I have for you to look at. Traditionally, when we talk about fractions, we have spent a lot of time comparing them to circles, which you'll see down here in the bottom row. This is a whole circle, a half circle, a third of a circle, and a quarter of a circle. So very familiar probably to anyone who's studied fractions before. We like the idea of pies and pizzas. It seems like there's always an abundance of word problems about pies and pizzas when we talk about fractions. And that's not a bad thing. Circles are a really great tool for being able to easily break them up into equal-sized groups that we can kind of anticipate what they're going to look like. There's only one way to divide a circle into 2 equal groups, 3 equal groups, 4 equal groups, and so on. At least in a simple sense, there's only one way to do that in an easy way. And so that makes them a great tool for teaching fractions. The problem is anytime we teach something new to students, especially if they're students who are prone to struggling, we have to be careful about not using the same model over and over and over again, because sometimes we can create some bad connections, some untrue connections between the concept and the model itself. So we don't want students to hear the word fraction and immediately think of a pizza. That's not a bad thing, but fractions mean something much bigger than that. Fractions are a part, a given part of any whole. It doesn't have to be a circle. It could, for instance, look down here, be a square. So in the same way that our first row shows fraction parts according to circles, my second row here shows fraction parts using a square model. So here we have, it's kind of nice that these are coordinated, a whole square, and when I line up my piece here, I find that I also have a representation for a half, because I could represent, or I could show 2 of these would fit in one whole. I have a third. I can show that 3 of these pieces would create one whole, and similarly I have a fourth. 1, 2, 3, 4. Same exact idea as the circle, except that I'm just using a different shape. And that may seem so simple, but you'd be amazed at the confusion that we can save students by just changing things up a bit when we're trying to demonstrate what a fraction looks like in a physical sense. I have another example here. These are bars, like fraction bars, which we could think of kind of like a tape diagram, where I can line up, this is a whole, this is a half, and I have 2 of them, which helps me to show a student that lengthwise 2 halves make a whole. Or similarly, 3 thirds, let me get my others here, can create the same length. And then for the sake of being complete here, I'll show you the fourths. So 4 fourths, whoops, as I drop them, 4 fourths also add up to one whole. So we have here representations of fractions as a typical circle, as a square, and as lengths or as bars that kind of remind us a little bit of tape diagram comparisons that we saw in previous chapters. What is the significance of this again? Not that these are the only methods. In fact, we can use rectangles, we could use triangles, which would not necessarily be the easiest thing to do and would probably require a little bit of knowledge about area and all of that, but it doesn't matter what our shape is that we're trying to divide into groups. In fact, it doesn't even have to just be shapes. We could also talk about a group of objects and taking a quarter of the group of objects. All of these representations are important when talking about fractions, and we want to be able to link them to materials that we can see and we can touch, and we also want to link them to real-world situations that, whether it be baking and cooking or a portion of a class. Later on we'll talk about ratios, not at this level, but at each stage of learning about fractions we want to connect it to something meaningful so that we can try to overcome that kind of age-old problem of hating fractions, to put it simply, because that's how a lot of students and maybe even some of you still feel about fractions. So the rest of the details regarding fractions are in Chapter 8. If you haven't already read it, there's a lot of diagrams. I figured that the material in there is best read kind of in the book itself, but at least you've got a chance to see what some of these materials can look like up close and personal. So enjoy the rest of the chapter.